Alrighty, this is Miss LaFour, and we're doing lesson 5-9 today. We're looking at when you're going to use law of sines and when you're going to use law of cosines. So when you have law of sines, you use it anytime that you can. Okay, any triangle that works, that can actually set up that proportion. And it happens to be when you have angle, angle, side, or angle, side, angle. You can also use it for side angle, but this is the one that gives us trouble where it might be no triangle, it might be one answer, it might be two triangles. Law of cosines, however, is used when it's side angle side, or if you just have side. This is one form, of the thing. The other form we used was isolated the cosine of the angle measure, and we'll use that in a bit. Now, when you have the one, like example 1, let's just jump right into it. We have, it says use law of sines or cosines. I would attempt to use law of sines every time because it is a little bit easier. So remember, the opposite ones go together. So this angle goes with this side, and then this angle would go with this side. So if I'm looking for that side, I'm going to call it side C because it's opposite angle C. Then I would have sine of 31 over 14 equal to sine of 36 over C. And then, of course, solve for C. Remember, you cross multiply and solve here. So this would be 14 times the sine of 36 divided by the sine of 31. And at this point, you're just going to plug it all in your calculator. We're going to round to the nearest tenth, just like we did on the other ones from before. And that ends up being, let's see, that one ends up being 16, and this is feet, because that's the units given in the problem. And then when we look at the others, let's see, for me to find the other side, I'm going to need to know angle B. So to find angle B is pretty straightforward. 180 minus your 31 minus your 36, and that gives us 113. So if I know angle B is 113, now I can use that to find the other one. Sine of 31 over 14 equal to sine of 113 over, let's see, that's side B. So side B would be 14 times the sine of 113 over the sine of 31. And yes, pull out your calculator, do the math, make sure you're getting these numbers. Okay, and that one ends up being 25. So when you can use law of sines, definitely use it. It's so much better. But notice how example 2, we're giving two sides and an angle. So this is side angle side. So we have to use law of cosines because the law of sines just won't work. So I'm going to go ahead and label this one. This side right here would be your side R because it's opposite of the angle R. So I know R squared would be equal to 17 squared plus 28 squared minus 2 times 17 times 28 times the cosine of the angle 87. So R is equal to the square root of all that. And of course, you're going to plug all this in. Pause the video as you need to get to be able to plug it in. Make sure you're getting all these right answers. And let's see, this would be 1,073 minus 952 cosine of 87, and it's the square root of that. Plug all that in, and we get that is about 32. Okay, and this is kilometers, because that's the unit they give us. So once we have that, then we can actually use law of sines at this point. We don't have to use law of cosines. So the best thing to do is to go for the next largest one. Okay, so that's what I'm going to do. So this would be sine of 87 over 32, that's the one we just found, equal to sine of angle P over 28. So P would be the inverse sine of, remember we're cross multiplying and solving here, and let's see, if we plug all that loveliness in and round to the nearest tenth, we get 60.9. Now to find the other one, just subtract from 180, the two angles that we have. That's pretty straightforward. Now in example 3, they don't even give us a triangle, but that's okay. We know how to draw a triangle, okay? Just draw yourself a triangle. Label it any way you want. It doesn't have to be to scale. It just can't be a right angle. Let's see, DE is 6, so that distance there is 6. EF is 14. DF is 18. Okay, so when we go to solve this, we've got all three sides. We have to use a lot of cosines. And your best bet, always solve for the largest angle first. Remember, the largest angle is the one opposite the longest side. So I'm going to use that other form of this. Remember, cosine of E would be equal to the other two sides squared minus the side opposite, that one squared, which is your E squared, over 2 times 6 times 14. Okay, so E would be equal to the inverse cosine of, and I'm going to plug this in my calculator and get a number here. Okay, so negative 92 on the top. On the bottom, I got 168. Okay, so E is equal to the inverse cosine of negative 92 divided by 168. Okay, so that gives me 123.2 degrees. So E is 123.2 degrees. Now, once I found that one, and it's an obtuse angle, which I knew, then I can use my law of sines here and then go to a different one. So I'm going to choose, I guess it really doesn't matter because they're both going to be acute. So I'm going to do angle F. Okay, so I'm going to put my line here and separate this out. So this would be sine of 123. Sine of 123.2 over 18 equal to, oh dear, I'm out of room. Let me move this over. Okay, let me move this over. Is equal to sine of F over 6. Cross multiply and solve, so that gives me F is equal to the inverse sine of 6 times the sine of 123.2 over 18, and then we just plug that in our calculator and find out F is 16.2. Now, of course, the last part is the easiest part because all we have to do is subtract these two from 180, and that tells us D, so 40.6. All righty. Now in example 4, again, they don't give us a triangle, so we're going to draw one. Okay, draw one here. WX, Y, WX is 9, XY is 15, W is 31. All right, so 31 is here. And we got to find all the missing parts. So let's see if we can figure that out. Okay, so this would be, oh, I can use law of sines here, huh? Because I can do this one. I can do law of sines. So awesome. Let's do that. Okay, so this would be sine of 31 over 15 equal to sine of, let's do y, over 9. So y is equal to the inverse sine of 9 times the sine of 31 over 15. And that gives us 18 degrees. So remember, we have to check, is there another one? So basically I say 180 minus my 18, and that gives me 162. But notice 162 plus the 31 that's in the problem originally, that one, that is greater than 180. That's greater than 180 degrees, because that's 193. So that one doesn't work. So I know there's no second one here. So angle Y is 18. So if once I find that one, I could just subtract that from 180 with the other one. And then that tells us X is 131. Now I can use law of sines to find side X here. Okay, so sine of 31 over 15 equal to sine of 131 over X. So this would be 15 times the sine of 131 over sine of 31. And X is equal to 22. All right, so now we're looking at the word problem. Cincinnati, Ohio is 540 miles due east of Kansas City, Missouri. The bearing from Kansas City to Nashville, Tennessee is south 64 degrees east. The bearing from Cincinnati to Nashville is south 29 degrees west. So that's, wow, that's going to be tough. Okay, so we're going to figure it out. I'm going to draw a triangle over here. Okay, so I know Cincinnati, Ohio is 500 miles due east of Kansas City. Okay, so east is on this side. So Cincinnati would be over here. Kansas City would be over here. That's 540 apart. And Nashville, south 64 degrees east from Kansas City. So imagine a line here drawn, okay, from the south. We're going to go 64 degrees to the east. So somewhere this direction, okay? So this would be 64 degrees from the south. Remember, this was south. The other one, okay, from south, then this one is, how far? 29 degrees to the west. All right, so 29 degrees. So that would be, this one would be 29 degrees. So somewhere over here it's going to meet, okay? And that's going to be your Nashville. So let's see, we want to find the distance from Kansas City to Nashville. So we need this distance here. All righty, let's see what we can figure out. Well, when we're looking at these, I'm noticing that this would make a right angle. Okay, and this makes a right angle. So I can find out the difference here by subtracting from 90. So this ends up being 61. This ends up being 26. So now I think we've got everything we need, right, to figure out that distance. Because if this is 26, it's 61. Oh, I can subtract that from 180 and get this one. So that's 93. Yeah, so now I have enough. So this would be sine of 93 over 540 equal to sine of 61 over, I'm going to call it C because that's the opposite that angle there. And that gives me, C would be equal to 540 times the sine of 61 over the sine of 93. So 472.9, and this is miles. The hard part is drawing the picture. Like if you have the picture, it's not as bad. So notice on this next one, find the distance from Cincinnati to Nashville. So that means I want this piece. So like, okay, we can handle that, right? We can find this distance because it's basically the same as what we just did. So this would be, we could do sine of 93 over 540 equal to the sine of 26 over, I'm going to call that little k, okay, for the first letter. And cross multiply and solve. So k would be equal to 540 times the sine of 26 over the sine of 93. So k is 237 miles. Alrighty, almost done. Last little bit. Okay, so this last problem, leaving from the same port, ship A sails 8 miles at a bearing of north, 45 degrees west. Ship B sails 14 miles at the bearing of south, 70 degrees west. So if you want to try to draw this out, just pause the video, see if you can draw it out. Okay, so I'm going to draw a little thing over here. Okay, so ship A goes north 45 degrees to the west. Okay, so 45 degrees would be here. This would be ship A, so I'm going to put A up here somewhere. We don't know what the distance is, but it doesn't really matter. We're going to figure it out. Ship B is 14 miles. Oh, wait, that's 8, so I'm going to put 8 here, 8 miles. 14 miles south, 70 degrees west. He's going further, so I'm going to do that. Okay, so this is 14 miles. This one would be 70 degrees to the west. So I'm going to say ship B is way over here. And we want, how far is ship A from ship B? So you need this distance right here. That's what you're looking for. Okay, so I'm going to call this C. So this is side C. So, I'm going to need to figure out this angle right here, but I know these add up to 180, so 180 minus 45 minus 70 will tell us what that angle is, and that's right there. So, okay, so now we have everything we need. I know C squared is equal to 8 squared plus 14 squared minus 2 times 8 times 14 times cosine of 65. And I can just put this in the calculator all at one time. Square root of all of that. And I get, let's see, that would be 260, 224 cosine of 65. So C is 12.9 miles. Now, if ship A sails to ship B, what bearing should it take? Oh, that one's a little more complicated. A goes to B. Let's see if we can figure this one out. If A goes to B, so I'm going to draw a north-south line here from A. So basically, I'm going to need, which distance is that? I need to figure out which distance. I need this piece. That angle right there from north, south, east, west. Okay, so yeah, I need to figure out what that is. Alrighty. Surely we can figure that out. If I find out what A is, maybe that would help us. Yeah, because I know this one's going to be right here. Oh, I'm on eraser. Sorry, guys. I know this one is 45. So if I can find angle A, I can subtract 45 and find it. So let's do that. Let's see, this would be sine of 65 over 12.9. That's what we just found. Then we have sine of A over the distance of A, 14. So A is the inverse sine of all that. So that tells us it's 79.6 degrees with a whole angle. If I subtract out that 45, because I don't need that piece, so that means the bearing would be south, 34.6 degrees west, because it's to the west from there. All righty, we have finished this. Wonderful.